So we are going to discuss about NLP, which is natural language processing. So what is natural language processing is we already know what is data science, getting insight out of data, which is a structured data, right? Usually till now we have studied about, and then in the previous classes we were discussing about text mining. So in the text mining we are discussing about how to get insight out of text data, and we saw some examples. So by the way, we have NLP in it, in understanding the insight out of the data. We also have NLP. NLP is important sub part of AI, artificial intelligence. So under artificial intelligence only we have machine learning. Under machine learning we have deep learning, and this NLP is also using this machine learning, deep learning, everything together. We can able to do this natural language processing, and it's an important part of artificial intelligence. Actually, what we want to do with this NLP, that is natural language processing, is the machine, we have to make give ability to a machine to understand the human language. For example, we talk to Alexa, right? Alexa, switch on the light, or set the alarm, or order this one, or call my friend by giving the name. So when I say all these things, the machine would able to understand what I am coming to say. Accordingly it is acting. So that is what the machine natural language processing, giving the ability to machine to interpret and understand the human language and respond back to human in the way they understand. Actually, machine will understand only zeros and ones, we know, right? And uh, still it is could able to record what we are able to speak, and then it is getting, so it is recording what we are speaking, converting it into text, and it is doing lot of process behind it, which we learned in the previous class as well. Like first getting the source, and then it do the normalization, wherein we have tokenization, removing the punctuation, stemming, lemmatization. Likewise, many processes do, and then it will understand what we are saying, and then it is responding back. So that is what we are going to learn in the. So actually, it is a very big, vast area, but we are going to see the glimpse of what is actually happening behind it. So that is what the natural language processing. So making the machine to understand what the human are supposed to say, and it is also responding back in the way human could understand. So for example, I may be, my slang, it may be different, the way which I speak English may be different, and the speed which I use may be different, the speed which you talk may be different. So every people have their own way of representing, communicating, pronouncing something. Everything is different, but we are making the machine to understand everything, right? If I say, okay, Google, you do this, means Google is doing something. And in Google we have Google Translator. Even we can give a voice command, or even we can type something. Whatever we do, it is responding properly, right? Even in the chat GPT, if you give something, and if you're asking it to translate or give the answer in Tamil language or Malayalam or Kannadam or Hindi, whatever it may be, it is doing promptly. So how it's happening? That's what the natural language processing. We are giving the machine the ability to understand the human uh, language, and it could able to respond back. So what it's actually happening behind, there is many processing happening behind it, right? So it doesn't, so for that we use machine learning algorithm, deep learning algorithms, and it is recording the voice, converting back to text, and then it has to understand the meaning of every word depending on the context it to understand. So many things, what is the relation? For example, I'll say John is a good boy. He goes to school regularly. So when I say John is a good boy, it's the first sentence. He goes to school regularly. So it should understand he refers to John. So many things in ChatGPT also, real time, you are all using ChatGPT nowadays regularly, right? So for example, if you know, first time I can give one question. Next time I don't want to say what is the context of it. When I give the related question to the first question, So it could able to relate the second question with the first question, and accordingly it is giving the answer. So depending upon the context, it is giving the answer. So it's all the like wonders of the natural language processing. So it's actually very tedious and complex problem to be solved, but it's all happening because of many steps which we already discussed in text mining, right? What are the text we saw? So it should take the data. So from the raw data is taken, then it should do what is POS tagging. Here are some things which we discussed in the previous class, right? It do POS tagging. What is PO tokenization? It do, and then it by the help with the tokenization, it do POS tagging. What is POS tagging? I hope you remember parts of speech tagging, and then ambiguity should not be there. So for example, when I represent one word in English, it has multiple meaning depending upon the context. So ambiguity should not be there. The relationship between the words should be obtained. So when we do all this only, it can able to properly give the answer back to us. So this all will be happening in the natural language processing. So what are the major components in this natural language processing? Is first one is natural language understanding. So when I speak something, first it should understand what I am speaking. When it is understand, it should then respond back to me. So that is what natural language generation. So these two are the major components of natural language processing. So first is understanding. So if we want to understand our speech, it should be converted into already we learned whatever I speak, it will be properly converted into another structured representation, so that we can able to apply some machine learning algorithms. We discuss k-means, we can apply SVM, naive, anything we can apply. Then we bring this unstructured data to a structured format. So the representation is very important. So when it is understanding, it has some of the complex issue faced by is some of the thing I have listed here. One is lexical ambiguity, syntactical ambiguity, and referential ambiguity. So what is lexical ambiguity means? For example, as I told earlier, when I am saying a particular word in English, it may be having many different meaning depend upon the context. See, for example, when I say present, you say, when I take attendance, you will say present. When I say I'm going to present this to my friend, so it represents I'm going to give a gift to my friend. So present is a lexical ambiguity because it has not only one meaning, it has different meaning. So it's a word level ambiguity, word level ambiguity. So depending upon the context, it should understand what is the meaning of it. So that is what lexical ambiguity means. Next one is syntactical ambiguity. Let's see an example for it. Here is an example given. For example, the professor saw the boy with the telescope. So when it has two meanings, right? One is the professor might be seeing the boy carrying the telescope. So that is with the telescope. That is one meaning. Another one is the professor is using a telescope. With that, the professor is sawing that boy. So the professor saw the boy with telescope. So one meaning is if he is seeing the boy through the telescope. One another meaning is the professor saw the boy who carry the telescope. So this may be having different. It's an ambiguous one, right? It has a confusion in it. So this is another ambiguity, syntactical ambiguity. So in all this context, the machine has to understand what I am coming to say. So if the machine want to understand, the professor saw the boy with the telescope, it should understand what is the previous sentence, what is the next sentence. Based on that only, it can come to a conclusion. This is what the meaning of this particular sentence. So this kind of confusion it creating is called as syntactical ambiguity. The next one is referential ambiguity. Let's discuss it with an example again. See here, John went to meet Sam. Okay, John went to meet Sam. He said, I am tired. So in this sentence, who said I am tired? We know. It should understand. He said, it can be John or it can be Sam. And so it should be properly understanding who is tired actually. John is tired. John went to meet Sam. He said. It can represent John or Sam. Who is actually exactly tired is what referential ambiguity. So it should understand the context again. Who is he? Who is I? Who is she? Or who is he? What is they represent? What is all representing? The madri, when we are using all this kind of terms, it should able to refer them properly. Okay, so this is what referential ambiguity means. So the understanding of the natural language, the human language is very important. So for that, it has to understand all this kind of situations. So first one is lexical ambiguity. So that is word level ambiguity. So depending upon the context, it should understand the meaning of each and every word we utter. And the next one is syntactical ambiguity, means based upon the sentence which we expressed previously or after that. So we have to understand the sentence. That is syntactical ambiguity. Okay. So the next one is referential. So when we use he, she, it, they, and all, it should understand. It should refer properly. Who does this particular term refer to? So this is all coming under natural language understanding. So components of NLP is of two types. One is natural language understanding. Other one is natural language generation. So once it understands what we are supposed to convey, then it should respond back to us. Us, we should understand, right? So that is what natural language generation. So for the generation of the text, again it has to convert. Actually, when it is doing this understanding, it do lot of process. As I told, it will be doing POS, it will do be lemmatization, it may doing stemming, it may doing many parsing, pre-processing, all this it will do. And after it understand it, it should generate a response back to us, right? It should convert those answers back to the way which the human understand. That is what called as natural language generation. So what are the things it's actually happening for generating the response to human back is it should take the relevant and important content for us to understand. So, as we saw some example here, okay, the professor saw the boy with the telescope, or maybe few sentences with that. So, you should understand the context. It should take the relevant matching word, and it should respond back. So that is what the next one is: selecting correct word with the proper meaning for and grammar in that particular context. Then text realization, and it should map the structure as well. So as I told, no referential ambiguity. So who refers to whom? So accordingly, if it is properly referring, then only it can map the structures and all. So if it is doing all those things, only it can able to respond back to me, right? So sometimes the response may be in a voice response. Sometimes we can the response may be a chat bot. IRCTC, when you go, we have a chat bar. So when I give a question, it is responding back to me. But Alexa, when we ask a question, it will respond back in the as a voice command maybe. So so how does it generate the answer back to me is what the natural language processing, by considering all the sub process. So it is doing understanding and then generating the response back. So this is a major component of natural language processing. The next thing is stages of NLP, natural language processing stages. So these are the different stages: lexical analysis, syntactic analysis, semantic analysis, disclosure integration, pragmatic analysis. I try to give make you to understand by giving examples, so that you can understand. Go through the book, but the book has some only theory. I'll add some example for each. Okay, first stage of natural language processing in its understanding is lexical analysis. What is lexical analysis is, first one is tokenization. That's what happened in the lexical analysis. For example, if I'm giving a very big sentence as I am speaking, no, it should understand what is, for example, I'm saying natural language processing means it's the ability of a machine to understand the human language and respond back to human in the way which they can understand. So I'm talking a big sentence. So what the lexical analysis will do means, it will take the bag of words, right? It will take all the words from this what the sentence which I talk. So for example, natural language processing means it's an ability. So every word is identified a single words, and then it should understand what is what a noun, what is the verb, what is adjective, pronoun, everything. It should tokenize it. That is what lexical analysis. So what does it say? Lexical analysis words and phrases in the language. It will able to recognize and identify the structure and formation of the sentence. So it divide the phrases into phrases or words or all these things. So that is what lexical analysis. Tokenization. Okay, tokenization means what? Whatever it is received as an input, it will separate each everything, maybe in the form of parts of speech tagging. The next one is syntactic analytics. What is syntactic analytics means? For example, as I told you an example in the previous class, right? I told result equal to number 1 plus number 2. So it is a instruction we use in any of the programming language, maybe Java. So when the compiler, so what is lexical analysis will do when I give the statement? It will say result is a what variable equal to is an operator, num1 is a variable, plus is an operator, num2 is a operator, a semicolon is a end of statement. Like that, it is tokenizing. That was. Then what a syntactic analysis will do? It will check whether the syntax of this is correct. So that is what compiler will do. What syntactic analysis here will do is it will check here what is actually for a programming language. It will check the syntax. That is what the rule for the programming language like Java or a Python or a C or C++. But for a text data, what is the rule? Grammar is the rule, right? So here, for the second phase for the syntactic analytics, it will check the grammar of the sentence. It will examine the grammar, whether the grammar, is it based, is the sentence or the input given is following the grammar or not. That and all of examine in the syntactic analytics. And so if it want to know, is it following the rules of the particular language. For example, the grammar of Tamil is different, grammar of Malayalam is different, grammar of English is different. So it should understand it and it should match to the grammar of the, for example, first it should be having a noun followed by a verb, then after that it should have this adjective, maybe some rules are there, right? So it will check all these things by checking the relationship among the words. If it know the relationship among the words only, then it can understand the grammar is correct or not. So the sentence is passed by noun, verb, subjective, and other part of sentence. So that is what syntactic analytics means. So it is tokenized, and then it is checking the syntax by finding the relationship between the words by giving a tagging like parts of speech. That's what noun, verb, and that's what said to be as noun, verb, adjective. We call it as the terminology for it is POS tagging, that is parts of speech tagging. The next one is semantic analytics. Now we check the rule, right? After checking the rule, I'll again come to the same example. I said result equal to num1 plus num2. Tokenization, I already told, finding what are the operators variables. The syntactic analytics means checking the rule, is it following the syntax of the particular programming. What is semantic analytics? For example, I'll say num1 and num1 is a integer variable, and num2 result is also integer variable. Num2 is a float variable. Okay, so actually syntactically it is correct. Result equal to num1 plus num2 semicolon. It's actually syntactically correct. Now it want to understand the meaning. What is the understanding of meaning? Result is an integer variable, num1 is an integer variable, but num2 is a float variable. So there is a mismatch in the data type of the variable. So what should it do? Since the destination variable is result is an integer, it has to convert the float back to an integer. Otherwise, for example, if the result is float variable, means the num1 has to be converted to a float variable, and then it has to do the addition to store the result back to the result variable. So it is understanding the meaning now. First it is checking the syntax, then it is understanding the meaning accordingly, then it should act. Same thing only here also. Semantic analytics means it should actually understand the true meaning of the sentence. First it is checking the grammar here by seeing the relationship, then it should see the actual meaning of the sentence. Okay, and so it check the sentence is meaningful, is it accurate, all this thing is checked by the semantic analytics. I hope you got what is this three step is about. What is the next step? So first is lexical analysis, we do the tokenization. Syntactic analytics means it will check the syntax, that is the grammar. Semantic analytics means check the meaning. The fourth one is disclose integration. What does this disclose integration means? For example, let's see an example so that you will understand it properly. So John went to store, he bought some apples. They were fresh and juicy. So to understand this, it has to do some disclosure. What are the thing it will understand means? Actually meaning it understood the meaning in the semantic analysis. Now it should want the in-depth context also. Okay, not only just understanding of the meaning, it should understand the background of that meaning, the context of that. So what are the thing it should understand in this sentence? John is there, here he is there, here they is there. So the meaning it will understand the meaning, but now it has to understand the in-depth meaning of it. So when I say John went to store, he bought some apples. So who bought some apples? John. So it should now refer, he refers to John. Other disclosure integration. For that it has so many steps. Okay, anaphora resolution. That is identifying he refers to John. Either it should understand this one. And then they were fresh and juicy. Who the what is this? They refers to, they refers to apples. Okay, and then third sentence and the second sentence refers to it. It is giving an additional meaning about the first sentence, that is cohesion and uh, coherence. So which means he bought some apple, they were fresh and juicy, talks about what John went to store. This two sentence is related to the first sentence. So recognizing all this relationship, additional information is what disclosure integration. I hope now you can understand. So semantic analytics mean understanding the meaning, actual meaning of the sentence. Now in that meaning of the sentence, you should understand the context of the sentence and the words present in that. Okay, so in disclosure integration, the meaning of the sentence get verified with the sentence before it and after it. So it's related to the previous sentence or it is related to the next sentence and all the context of it. So I hope you understand what is disclosure integration. The last step is pragmatic analytics. What is pragmatic analytics means? It is a meaning of a sentence in various situations. So for example, you take as example here, it's cold in here. Okay, it's cold in here. Your sentence, it's a sentence. So for example, I'm saying, if I'm saying to a machine it's cold, or if for example I'm saying to you it's too, I'm sitting in my place and I'm saying it's too cold. So what you will understand, you, for example, you are present in my cabin and I'm saying it's too cold. So how will you react? You will say, ma'am, shall I off the fan, or shall I reduce the speed of the fan? So what you are doing actually here, that is what the pragmatic analytics. I'm just saying it's cool here. So you understand the meaning depending upon the situation and then you are going to react on it. So that's what the real world knowledge of that particular situation. So that is what pragmatic analytics. So this phase deals with the meaning of the sentence in various situations. So the sentence will be verified by the context and the place where we are in. So that is what pragmatic. So the literal meaning is, it would be actually the literal meaning, and what is the meaning? It's cold here. The pragmatic meaning, based upon the situation, it should react on it. Okay. So the indirect way of understanding the meaning depends on the context where we are saying it. Okay, so these are all very important thing in the stages of NLP. So what are the stages of NLP? Lexical analysis, syntactic analytics, semantic, disclosure, and pragmatics. Lexical means tokenization, like separating everything, understanding what it is, probably maybe taking every words, getting a bag of words. Then syntactic analytics means maybe like POS tagging, right? What is POS? Parts of speech tagging. So this is a noun, this is a verb, this is an adjective. Likewise, identifying it and checking the grammar of it. Then semantic analytics means after checking the grammar or the meaning or the checking the rules, it has to now understand the actual meaning of each and every sentence, words present in it and its relationship. And then what is disclosure integration? So now when we have a text input, it should understand the context of each and every word, which word referred to what, and what is the relationship between one word with another word. All this thing is disclosure integration. What is the final pragmatic analytics? I am saying a word or a sentence, but depending upon the context where it is uttered, it should be responded based on it. That was pragmatic analytics. I hope you got it. Okay, so next one is statistical processing of natural language. What is statistical processing of natural language means? For example, if I want to understand all this natural language processing, as we have already discussed in text mining, it is unstructured data. So if it is unstructured data, we cannot apply any mathematical algorithms, formulas, nothing we can do, right? So we have to convert it to a structure format so that we can get so that we can apply some mathematical model to it to understand or predict or to analyze or to respond to the particular input or a text. That is what the statistical processing of language. So it refers to use of mathematical models and statistical techniques to analyze. So if this to be happened, okay, if this to be happened, then what you have to do, you have to convert all this to a structured format. So that is what presented here. So as we discussed earlier, what are the steps we did? We related, we made a syntax analytics so that you can bring it to some collection of words. We can separate to different sections. These words are all related to this positive statement. This words relate to negative statements. All these things, right? So this is all, like for example, you have email. In email, when it is, that is also another natural language processing. It is going through the content of the email and it is checking whether it is a ham mail or a spam mail by analyzing the meaning of the words belong. So if it want to do all this thing, it should do some statistical, we have to apply some algorithms. The algorithms can be applied only to the structured data. For that, we have to do a lot of structuring here. That is what the statistical processing. So in the statistical processing, we have two steps. Okay, two stages are there for statistical processing. The first stage is document pre-processing. Actually, these two lines are only present in your book, but I have given some examples just for you to understand. So, if as we have discussed many things in the previous topics, pre-processing means what? As I told you in the previous stages of NLP, what is the first thing? Lexical analysis. So here also, when you do this pre-processing, it has to do tokenization. What is tokenization? Separating each and every words, right? Splitting the text into small units, words, and also I love NLP. So it is tokenizing. I love NLP. So yeah, it is a punctuation. So it should able to recognize each and every words. And then the other pre-processings are like convert everything to lowercase, removing the punctuations, removing the common words like is, was, each, they, and all. And then stemming and lamentation. Already we have learned in the previous classes what is stemming, lamentation, punctuation removal, handling special characters. So these are all what called the pre-processing. Okay, document. This consists of preparation of the document to eliminate or to get it, make it ready to do the processing or to apply statistical or mathematical formula to our input data. The next one is parameterization. So what is parameterization? The steps involved in parameterization. So the stage of removing the complexity, right? Minimizing the complexity. Then only, because text is tedious data, as we have already discussed, it has many ambiguity, many meanings, many things related to the context and the situations where it is uttered. So to minimize the complexity, we have to do some certain steps. That is bag of words, And the TF-ID, I have showed you example in the previous class. Hope you remember that. So term frequency, and we find the documents frequency. So all these things I showed you formulas, what is happening there, how it is finding the frequency of a word. For example, when it is seeing word super, so it apply a formula, how it is related, how well this particular word is important for this context. So all these things will be done in the parameterizations. Okay, word embedding. So word embedding for a particular word, what word can be replaced suitable for it to make you to understand and to apply to the particular statistical methods. So this is what parameterization. Okay, so this is about statistical processing. Have two stages. One is document pre-processing, the stages which remove and prepare the document for the next level, and then parameterization, removing or minimizing the complexity of the document. The last topic of it is application of NLP. So we know the day-to-day applications, virtual assistant, right? So when we answer a question, ask a question, it is responding back. Sentimental analysis. So is it a positive comment? Is it a negative comment? Is he is happy or sad? To all the sentiment analysis. Automatic summarization. When I give a big para, for example, and I'm giving a book to this, and I want to know the summary of this textbook. So that is what summarization, right? So it should understand the context and it should give a small abstract of your particular input. Then machine translation, I can convert Tamil to English or Malayalam or whatever, speech recognition. So every so when it want to understand, it should understand who is speaking. Actually, it can easily understand the persons in the house by its. We even cheat humans, but the machine can easily understand whether the mom is speaking or the dad is speaking or the children are speaking. So all these things can be recognized by various. So if it want to happen, it should do all the things which we have already discussed. The steps need to be followed. So these are all the different what applications of NLP. Okay, so these are some of the algorithm which we use in stemming. We know what is stemming, right? Already we have learned by removing the affixes or suffix of a particular word. So for doing that, we have so many algorithms. Potter stemming algorithm, Lancaster stemming algorithm, regular expression stemming algorithm, snowball stemming. These are just, some algorithms. So here, I hope you all understand the what is actually the overview of natural language processing. Okay, I hope you got understand